Thank you, Karna. Good afternoon, everyone, and thanks for joining this webinar. Today we will talk about a useful tool that we call AgroTagger. This is a piece of software that can be used for the automatic indexing of bibliographic metadata, extracting keywords from the AGROVOC thesaurus, even if you could train the engine behind the tool with another thesaurus. Anyway, AgroTagger was tuned to be used with AGROVOC. So before starting the webinar, I would like to give you some definitions. I told you that the AgroTagger extracts keywords from the AGROVOC thesaurus. I don't know if all of you know what AGROVOC is. AGROVOC is the FAO multilingual thesaurus containing more than 32,000 concepts in 22 languages. It has been exposed as linked open data, and there are both a public Sparkle endpoint and web services to use it. You can have more news on the IMS website. AGROVOC covers all areas of interest to the Food and Agriculture Organization of the United Nations, and so also the Agris domain. Agris is a database of more than 7 million bibliographic references in agriculture, with a web portal where you can search for scientific researches. It is also a collaborative network of more than 150 institutions from 65 countries that collaborate to publish their data. Agris metadata are enhanced by AGROVOC descriptors, and this is very important to Agris, as we will see in one of the two use cases for the AgroTagger. This is the outline of the webinar. I will give you some ideas about what is the AgroTagger, how does it work, and then I will show you two use cases that highlight the usability of the tool. Now, first of all, I want to disambiguate the term AgroTagger, since we refer to AgroTagger to define different tools. Generally, AgroTagger is a keyword extractor that uses the AGROVOC thesaurus to enhance bibliographic resources. Now, we have different tools called AgroTagger, and only one of these is the tool that I'm going to introduce to you. First of all, AgroTagger is a tool developed in collaboration with the Indian Institute of Technology of Kanpur in 2010, and it was built on top of the popular keyword extraction engine, Kia, and you can follow the link to have more information about Kia. Then there is also a web application developed by MIMOS, which is the FAO Center of Excellence in Malaysia, in collaboration with the Indian Institute of Technology of Kanpur and FAO. More information about these two tools are available on IMS. But AgroTagger, the word AgroTagger, refers also to a command line application. The tool I'm going to show you today is this command line application, and it comes without a graphic interface or a web service on top of it. It is a Java API based on MAUI. MAUI is a piece of software to automatically identify main topics in text documents. It builds on the key phrase extraction algorithm Kia, but provides additional functionalities, and it also has many new features that help, for instance, to identify topics more accurately. Just to say something about the origin of the name, Maui is the name of a Polynesian hero who was able to transform himself into different kinds of birds. So this application is called Maui because the MAUI algorithm assimilates two software tools that are Kia and Wika, that are also the names of native birds in New Zealand. So this is just to give you an overview about the name. How does MAUI and the AgroTagger work? So the purpose of the AgroTagger API is to index web resources using the AGROVOC thesaurus. Indexing web resources means that the input of the application is a set of URLs. So these URLs can come in two ways. The application can take as input a text file with a URL in each line, or the output of an Apache NATS web crawler. And we will see this situation in the second use case, because we are trying to crawl the web and using the AgroTagger to assign AGROVOC URIs to the resources that the crawler is able to discover in the web. But I want to show you a simple diagram to highlight better this situation. So in this picture, I draw the AgroTagger as a box. So it is not so important to understand the code behind the application. It's a box based on MAUI. The input of the application is a text file with a list of URLs of web resources. The output of the application is an RDF file. This RDF file contains, for each URL in the input file, a set of AGROVOC URIs extracted by the AgroTagger. So in this example, the serialization format of this RDF is in triples, but of course you could have even XML. So the important thing is that starting from a set of URLs of web resources, the AgroTagger is able to read these resources and to assign AGROVOC URIs from 5 to 10 AGROVOC URIs to each of these resources. So the algorithm is very easy. We have a set of URLs as input. The application has to download the resource in order to read the entire resource. Then run the MAUI indexer trained with AGROVOC. In this situation, we train the application with 780 bibliographic resources manually indexed by FAO catalogers. So this is the part that you can modify if you want to use another thesaurus. You have to train MAUI with another thesaurus and then change only this piece of software in order to run the indexer with a specific thesaurus. Then, of course, the application has to update the output file with the discover connections. Using the word connection, I mean the association between a source URL and a set of AGROVOC URIs. Now, after this small introduction, I want to show you two practical examples of application of the AgroTagger. First of all, we use the AgroTagger to index Agris resources. I have already introduced Agris to you. Agris is a collection of more than 7 million bibliographic references in agriculture. The most of the time, Agris records come with AGROVOC descriptors, and this is very important in the Agris system because since December 2013, Agris was also an RDF-aware system. This means two things: that the Agris database is exposed as RDF, so there is a Sparkle endpoint to query the database and so over. And then that the system relies on AGROVOC keywords to interlink to external sources of information. So what is the situation? We have a graph here. As you can see, this is a page in Agris that we call mashup page. The scenario is that the user is looking for some resources in agriculture and he or she comes to an Agris record. On the left of this page, there is the content of the Agris record. So as you can see, there is a title with a date. There is the set of authors of this reference. There is an abstract. And there are also some AGROVOC keywords. And this is very important since we use AGROVOC keywords and URIs together with linked open data technologies or web services to dynamically extract from the web information related to this record. So AGROVOC is very important to build this process. So for instance, here the first AGROVOC keyword is the maize, and as you can see, we can extract the distribution map of the maize from the Global Biodiversity Information Facility. We can also query the World Bank repository, the Biodiversity International, Nature.com, DBpedia. But the fact is that AGROVOC is important to have this magic, to have this tool, to show everything in one page. You can say, what is the problem? The problem is that sometimes Agris records have not been indexed with AGROVOC keywords. So the situation is that when AGROVOC keywords are not available in an Agris record, the Agris record cannot be interlinked to external sources of information. It is a standalone piece of information, a static piece of information. The user can read probably the abstract, the title, sometimes the full text of the publication, but without other meaningful information. So the user has to go to search Google to find related information. So this is the situation without AGROVOC. We need AGROVOC in Agris records. And this is the solution. So at the beginning, an Agris record is an XML file. Since we want to expose Agris records as RDF, we have to triplify the record. We have to transform a simple XML file to an Agris RDF file. The algorithm checks if a record has an AGROVOC keyword or an AGROVOC URI. When there isn't an AGROVOC keyword, but there is the full text link, we can run the AgroTagger, since, as I told you, the AgroTagger needs the URL of the resource, so the full text of the publication, in order to download the resource, to run the MAUI AutoTagger, and then to generate triples with the associations between the resource and the set of AGROVOC descriptors. And the algorithm works well. Another problem is that many times we don't have full text links, or if we have full text links, they can be broken. So the solution would be, and I say would be, using Google APIs to look for the full text. And here can come different problems. So for instance, Google APIs are not free. You have to pay after a given limit. And then it is not true that Google can find the full text for all the publications. So we have to implement this second part of looking for the full text using Google APIs. But we were able to use the AgroTagger inside the Agris system to enhance records that came without AGROVOC descriptors. Here is an example of the application of the AgroTagger to this use case. In 2012, Agris received from the World Bank more than 25,000 bibliographic records. These records were really nice, with titles, abstracts, authors, also with full text links, but there weren't any keyword associated, neither as AGROVOC descriptors or as free keywords. So these records were useful for the user to look for scientific research, but they couldn't be enhanced with related information extracted from the web, so with statistics, with distribution maps. The only solution was to run the AgroTagger. In this way, we were able to assign from 4 to 10 AGROVOC keywords to each World Bank resource. The first time we applied this procedure, we did also a manual check. So we had a cataloger here in FAO who manually compared the keywords extracted by the AgroTagger with the manual indexing of the same resource. And the results were really good. Sometimes the AgroTagger extracts keywords that are more general than the ones that a cataloger can use. But we had really good results, and we can say that the AgroTagger is reliable in discovering keywords in the agricultural domain. So this is the output of applying the AgroTagger to World Bank metadata. As always, On the left, you can see the record, so the title, the abstract, and the full text link coming from the word bank. Then there is also a set of AGROVOC keywords, but these keywords were assigned to these records from the AgroTagger, and these keywords were necessary to show all the information on the right. So the map from the word bank, other bibliographic resources from nature.com, definitions from Wikipedia. And without running the AgroTagger, this was simply not possible. The user had simply to see the abstract and the link to the full text. So we try to give the end user a great experience of the system and of the research in agriculture. The second use case is the one that I was trying to tell you before, and it is to say crawling the web. This is the setting. So what we want to do is to discover web resources in agriculture and interlinking these resources to Agris records. Why this is important? Because we want that when the system displays to the user an Agris record, also a list of related web resources should be available to the user. So in the previous situation, we saw that starting from an Agris record using AGROVOC and the linked open data technologies, we were able to query external databases, so exposed as RDF or web services, in order to automatically extract this information from these databases. Now we want to give to the user also a box in the same mashup page where there are some links, some URLs that the user can look, can be interested in, because they are related to the record. And we are sure that these URLs are related to the record since we used the AgroTagger to assign AGROVOC URIs to these web resources. In this situation, the AgroTagger is not enough. We need also a crawler to discover resources. In this situation, we used an Apache NATS crawler. Of course, we had to tune the software together with the AgroTagger Java API. This is the algorithm, or better, the flow of the information between the two tools, the two pieces of software. There is the Apache NATS web crawler that crawls the web starting from a list of preselected URLs. So we have to choose from the web some trusted URLs, and the crawler starts to read the content of this URL, discovering other URLs and navigating the links. The output of the crawler, that is a list of discovered URLs, is given to the AgroTagger. Now, the AgroTagger, as we saw before, is able to assign some AGROVOC URIs to each URL discovered by the crawler. Then there is another algorithm that tries to compare the output of the AgroTagger with the contents of the Agris database. So when can we connect an Agris record to a web resource discovered by the web crawler? When they have at least 5 common AGROVOC URIs. So this number 5 has to be tuned. We are in the middle of some test to tune the process, to tune the workflow in order to make it available to the end user. But results are quite good, and now I will show you also some numbers in the next slide. Yes. This is the last test that we did. We started from this URL, giving this URL to the web crawler. The crawler was able to extract, starting from this URL, more than 100,000 distinct web resources. And then the AgroTagger, of course, was able to assign some AGROVOC URIs to each of these web resources. Then there is an algorithm that tries to match Agris data to these resources. And here is an example. We were able to assign this PDF file discovered by the crawler to these Agris records coming from the US because they had at least 5 common AGROVOC URIs. Now, the number of the common URIs that we need to assign a web resource to an Agris record is very important. It's very important because of numbers. The number of connections that we create can explode. For instance, when we set the number to 3, so we assigned a web resource to an Agris record if they had at least 3 AGROVOC URIs in common, we were able to discover more than 70 million of connections only for the first 900,000 Agris records. Remember that Agris is a collection of more than 7 million bibliographic resources. So only for 900,000 Agris records, we were able to discover 17 million of connections. While if we increase the number of common AGROVOC URIs needed to do the connection, you can see that numbers decrease. In fact, for 2.3 million of Agris records, we were able to discover 1.2 million of connections. So the tuning here is important. This is another reason why we are still in the test phase, because it's very important to understand the parameters in order to avoid unnecessary connections or too many connections. We want to give to the end user precise information to associate to Agris records, so to the navigation of the Agris web portal. Now, these are the things that we need to do for the future in order to improve both the AgroTagger and these two use cases. First of all, other qualitative and quantitative tests. I mean also the tuning of parameters, both for the crawler and for the matching algorithm. In fact, we saw some numbers about the matching algorithm, but also the web crawler has to be tuned in order to go deep in a web page in discover URLs. Then we need also an optimization of the algorithm to run faster, because at the moment the AgroTagger is working in the following way. It starts from a list of URLs, and for each one of these URLs, first of all, the AgroTagger downloads all the web resources, so there is no parallelization at the moment. Then it runs the MAUI algorithm. At the end, it writes the output file, so the RDF file. It will be very good to split the job, so to run different jobs on subsets of the source URLs in order to improve the performances. But for the moment, we are tuning also the rest of the algorithm, but this is one thing that needs to be done in order to improve performances. Then we need the tuning of the physical infrastructure, because of course all these procedures are really expensive in terms of CPU consuming, RAM, and so over. What we want to do is, for instance, trying to install the application over a cloud and see if performances can improve using a cloud as an infrastructure for the application. Also because the application has to download the resources, so we need also a location where there is good internet connection, where there is a big space to store this information and other things. So the tuning of the physical infrastructure is fundamental to use the application, I don't want to say real time, but with a good time. And then of course all these procedures should be automatic. I mean that in the process of the Agris data flow or also in other system, when you receive metadata, there should be a piece of software that catch metadata, run the AgroTagger, and extract keywords for this metadata. The overall objective is to reach the final goal, so that when the system displays an Agris record, a list of related web resources are available to the user. Just to show you where they can be positioned, for instance, in this Agris record, on the right there are the information that are extracted from the web querying databases, but we need to have an endpoint to query. So an HTTP service that can be queried and that returns some information. This situation is new. We don't want to query external databases. We want to query documents stored in the web, so websites. And there are no ways to say that a website, a web page, a PDF document is talking about a specific topic. On the other side, we want to be sure that what we show in this page to the user is semantically related to the content of the record. So it is necessary to index also web resources with AGROVOC, and the AgroTagger at the moment for us is the only solution. So the AgroTagger can be used both to index metadata, in this situation using the AGROVOC thesaurus, but also to index web resources. And I think that for the moment that's all. I guess that you have some questions if you want to go more in details about the algorithm, the software. I wanted to show you more how the tool can be used in real scenarios rather than knowing you with details about software algorithms. But